Greetings, it's the Digital Dog once again, and today I have a new video which is a extended recap of an article I wrote called Why Are My Prints Too Dark? I thought I would update it and include a little bit more detail on this troubling subject that so many people seem to have. Here's what I'm going to cover today. Are your prints really too dark? It's important to test this. I'm going to talk about how to overcome this particular problem, which is display calibration and the goal of WYSIWYG, or what you see is what you get, within reason. A critical part of producing WYSIWYG is having proper print viewing conditions, and I'm going to go over to that. And then what I'll do is I'll talk a little bit about troubleshooting so that you can get a match between your display and your print. So the first question is, are my prints really too dark? A print obviously can be too dark, and what we need to do is evaluate whether or not the print is outputting too dark or whether or not it just appears too dark under a particular condition. So we need to look at a print under different appropriate illuminations to see whether or not it really is too dark. Even the best quality print can appear too dark if it isn't properly illuminated, and I'm going to show you an example of this. One of the first things you want to do to evaluate whether or not your prints really are too dark is to use a color reference image to test your output and then use your own images. I'll show you some examples and explain why this is a critical step. Now, photographers have been making prints for over 150 years, and yet this concept of prints being too dark is relatively recent. I believe one of the big problems is we have an intermediary device, a display. If the display appears too bright or much brighter than the print appears too dark in comparison. So that's one of the reasons we need to evaluate whether or not the prints really are too dark. In many, many cases, people who report that their prints are too dark are really telling us that their prints are darker than their display. And calibration of the display is absolutely critical. We need to calibrate our display so that when we view a print next to the display, under proper illumination that's controlled and consistent, they appear to match each other. Here is an example, a visual example of what I'm talking about. The display on the far right is a modern LCD display. The display in the center is an older CRT display, an old Sony Artisan. And to the far left is a print viewing booth with a color reference image. Now, currently in this image, what we're seeing is the print being illuminated by this fluorescent GTI booth. What I'm trying to illustrate here is that you don't have to necessarily purchase a very expensive print viewing booth. You can use something as simple as a Solex task light, or you can build your own print viewing booth. But what's important is that we have consistency. What you're seeing here is that on the far right, the display is set for what is called 150 candelas per meter squared. And candelas per meter squared is just a metric of luminance. So the display is set for 150 candelas per meter squared to match the viewing booth on the far left. This particular booth has a digital dimmer in the bottom left corner, and I can raise and lower it to any value I want between 0 and 100%. It's currently set at 80%. Now, the two, although you don't see it necessarily in this capture, they do visually match when you look at them side by side. The display in the center looks too dim because its maximum backlight intensity is 95 candelas per meter squared. So what do? We either have to lower the print viewing conditions on the booth, or if we're using the Solex lamp, move it further away, or raise the luminance, which is not possible with this old display technology. What we want to have is a display, and about 90 degrees from that display, a print viewing booth or method of consistently, correctly viewing our prints. And we want to make sure the two of them match in intensity. And we can do this either by raising the backlight intensity of the display or raising or lowering the viewing conditions within reason. Now, in order to test this all out, what I recommend you do is download a color reference image. And there are a number of them on the web. Some of them are free. There are 2 on my website. There are others on the web that you can download. And you want to use this for testing because the RGB values in these particular images are correct for output. That means that if your color management workflow going out to print is sound, you will not get a print that is too dark. Obviously, if you're using something like an inkjet, you want to let this print dry down for several hours before viewing. And it's also a very good idea to view these color reference prints in different locations. Under the print viewing conditions next to the display, maybe outside during daylight hours, in a room that has adequate illumination. And I'll talk about this more in detail. But the idea here is that you have an RGB document that, when output correctly, will not be too dark. And that's why it's called a color reference image. If the print appears too dark no matter where you view it, then you've got a problem somewhere else in the color management chain. It could be an incorrect profile, it could be incorrect print driver settings. But basically, if the print looks good, it isn't too dark, no matter where you view it in an appropriate illumination, then we know we can move on and use your own images and try to make a match to the display. So here's two examples that you can download from my webpage. I've got the URL up where you can download them. They're free. The image on the left is a very wide gamut image in ProPhoto RGB. The image on the right has gradients going from black to white. Will help you decide whether the print really is too dark. It happens to be in Adobe RGB. And I left a URL for a really great set of color reference images called Roman 16. These are not free. This is a highly recommended set of color reference images. But the two that I referenced on my webpage should be sufficient to use for deciding whether or not your prints really are too dark and for calibrating your display for a match. Now, the question is, are your prints too dark? Yes or no? Now, before I get into detail about these two images, we need a full disclosure here. The images that you're about to see are a simulation only. And I don't want you to think that because I set up these two images under two different viewing conditions, this is exactly what I perceived. Brightness is a perceptual, subjective phenomena, and the camera that captured these two images doesn't behave that way. But the point I'm trying to make is the image on the left, which is the set of Roman 16s with output, and when viewed under my GTI light booth, absolutely does not appear too dark. And if I take this print outside or in another room in the office, if I look at it under adequate illumination, it doesn't look too dark. The same print when viewed on the right under a nightlight bulb, which only has 250 lux as measured by my i1 Pro, appears too dark. And of course you can see that it's not evenly illuminated. It's brighter in the center than it is surrounding the print. The point is that the best looking print that you could ever imagine is going to look too dark if it's not viewed under proper illumination. The print on the left, under my GTI viewing booth, when measured, produces 1625 lux as reported in this software. And the image on the right has a mere 250 lux. So it's just too dim and the print looks dark. Now you might say, well, that's obvious. But so many people are not viewing their prints correctly next to the display or viewing the print in a proper illumination compared to the display that the print appears too dark. But in actuality, it is not. Here's one more example where I popped the print up against a wall with direct sunlight coming in, and the upper left-hand corner is slightly folded over and there's a slight shadow. At this point, we're viewing the print with 10,700 lux as reported by BabelColor CTNA, and yet it doesn't look too bright or too dark. Our eyes adapt to the new illuminant, both in terms of its intensity of brightness and the white point. So what's critical here is that you view the color reference image in different lighting environments that are appropriate, come to the conclusion that no, the print isn't too dark, and then we need to go and calibrate the display so that it matches the print. So display calibration is really key in getting the display to match the print next to the display. One size does not fit all. If I'm working with a matte paper that has a really warm substrate, it's going to look different under my viewing booth than a glossy paper with a cool white substrate. So I'm going to need a display calibration for both. And this gets tricky for some products that only allow one calibration, but we'll talk about that in a minute. The two critical areas when you calibrate your monitor that the software is going to ask you to specify are the backlight intensity, which, as I talked about earlier, is almost always defined in a numeric value called candelas per meter squared. The second most important calibration aim point is the white point of the display. Is it a warm color? Is it a cool color? Where does it fall in line? What values do you set to match the print? Some products allow you to actually calibrate the contrast ratio of the display by adjusting its black point. And this is very useful. If you look at specifications for displays these days, you'll see that many of them exceed 1,000:1 contrast ratio and vastly more. So you've got this display that has a huge ratio between its blackest black and its whitest white. And yet the best quality print is probably going to have about a 350:1 contrast ratio. So there's a really big disconnect there. If you can calibrate your display's contrast ratio that's closer to the actual contrast ratio of the paper, you're going to get a better match. Unfortunately, not many products allow you to calibrate a display to do this. Anyone that tells you that you should always use a particular value, like 90 candelas per meter squared or a white point of 6500K, at best they're giving you a starting point. The worst thing you can do is simply put those values in, calibrate your monitor, and think you're going to get a match. Unless someone knows exactly how your prints are going to be viewed next to the display, any value they give you is at best iffy. You're just going to have to use trial and error and get the values that produce a match. Those are the correct numbers to use. Now, in terms of what to set the backlight intensity for calibration, lower is usually better for two reasons. One, you're going to save energy and your display is going to last longer. But not all displays can produce very, very low native values. And when I say natively, what I'm talking about is the ability to adjust a very low backlight intensity in the panel itself. Many displays will allow you to set a very low value using the display's backlight to reduce the intensity. What they're going to do is just try to darken things using a color lookup table somewhere in the graphics system. And that really is going to introduce more banding into the display path. You want to avoid that. Out of the box, a lot of new LCD displays are hard pressed to get much below 140 to 150 candelas per meter squared. So if you read somewhere on the internet that you need to calibrate your display to 90 candelas per meter squared, you can pretty much ignore that for two reasons. One, you probably won't be able to natively calibrate the display that low. And two, as I said, if the person doesn't know how you're viewing your prints, that value of 90 is really worthless. Now, the display I'm using, which is a PA series from NEC, can natively calibrate in the panel as low as 40 candelas per meter squared. Keep in mind that you can also control the intensity of the print viewing conditions. I showed you on my GTI light booth that I have a digital dimmer that I can raise or lower to match the print viewing conditions closer to the display. And if you're using something like a Solex bulb or some sort of lamp, obviously the further you move it from the print, the less illumination is going to strike the print, so you can do some controls in that particular method. A digital dimmer on a conventional bulb will change the white point of that bulb. That's not a good way to control the brightness that you see striking the print itself. The other calibration aim point that we need to set is the white point of the display. And that's usually defined in either a Kelvin value, which is a correlated color temperature value, or using a standard illuminant value like D65. And again, your mileage may vary. The color that you select is going to be based on a number of factors: the print paper, the lighting of the print next to the display, and of course the display itself. The correct value is the one that produces a visual match. The other thing is that few software products really give you the kind of control you need to fine-tune this important setting. If you have a product that has just a few presets for color temperature, chances are you're not going to be able to nail this important value to get a match. And I'll give you an example in a second. Here's a URL for more information about the PA series displays I'm using. So this is the software I'm using currently from NEC. It's called SpectraView. And what you can see up at the top, target settings, I have a drop-down menu currently set for AR's photo editing. And this is one of many settings that I have, in this case, to match an Epson printer using luster paper to my display. The white point is set for 5750K. Why? Why not 5500 or 6500? Well, as I was going through the trial and error process of calibrating and viewing the print next to the display, 5750K was the value that produced the white point that matched the paper that I was viewing. I have the display set for 150 candelas per meter squared, as you can see on number 3. Why 150? Well, 150 was the value that produced a brightness match between the display and my GTI viewing booth. And lastly, I've set the contrast ratio to 300 to 1. Again, a little bit of trial and error, but all of the settings I've discussed were set simply because when I view the image in Photoshop or in Lightroom with a soft proof, and I look at the print next to the display, I get a visual match. Over on the right, I'm just showing you how I can go and set the custom white point in many different ways. I have it set for 5750K. There's an option in the software where I can set the values for 5750, 5751. I have a very fine level of granularity to set the white point. There's also an area below that is not on called Visual Match where I can simply move sliders and values until I get the appearance of a match for the white point. So having this kind of control is really critical in getting the best match between your print and your display. So viewing the print and the display. The goal is what you see is what you get. And 100% match just isn't possible. We're looking at a emissive display and comparing it to a reflective print. But what we want to do is get as close as possible. The less guessing we have to deal with, the more likely we're going to get that print the first time. What you want to be sure you do is to calibrate the display with the soft proof setup, with the paper profile you're going to be using, and very important, you need to have the customized proof setup set such that the simulate paper color and simulate black ink checkboxes are on as seen here. This is going to give you the most accurate, correct preview of how the image should appear going out to a print. Now there's a lot of controversy about whether soft proofing works or not. I'm not going to get into that. It works very effectively for me because of the steps that I'm following and discussing with you. But it's very important that the simulate checkboxes be on when you're viewing the image on screen and the print at the same time. If you're simply editing the image with a soft proof and you're not really looking at the print next to the display, you can turn those checkboxes off because often it looks a little ugly. As they say, reality kind of sucks, but those simulation checkboxes are going to give you the best preview of how the image is going to print. So again, soft proofing is only as effective as its weakest link. You've got to have good ICC profiles, you have to have good calibration software for your display, you've got to have proper viewing conditions, you've got to have an environment where the light isn't constantly changing. It should be as dark as possible in the digital darkroom you're working at. But the bottom line is that the calibration aim points that you select for calibrating your display are the values that produce a visual match, and those values will change depending on a number of conditions. Now, people say, well, what happens if I move the print to another location? Well, you can test this when you download those color reference images. If you take the image to another location, now the display is sort of out of the equation. Again, the goal was what you see is what you get. We looked at the display, we looked at the print, we produced a visual match. Now, once we move the print to another location, as long as it's not a 6-watt nightlight bulb, as you saw earlier, as long as it's adequate illumination, your eyes will adapt and the print should not look too dark. And if you don't believe me, download those color reference images, print them out, and move them around from location to location in adequate, acceptable illuminant, and they shouldn't look too dark. Your eye will adapt to the new conditions. Fix the problem at the source. Ignore the kludges. Here's a perfect example. Here's an image in Lightroom, and the image is too dark. I can see this from viewing the histogram. I can see it from looking at the LAB values I have set over the highlight near the dog's head. And of course, I can see it on my calibrated display. Increasing the brightness on the display is not going to fix this particular problem. The RGB values are wrong. The fix is to move the exposure sliders as I've done here. You can see the histogram looks much better. It's got a better distribution. And you can see that the LAB values are more appropriate. Now I have a little bit of headroom. My brightest highlight is an L star of 96.1. 100 would be pure white. Here's another major kludge that you want to ignore. It's the print adjustment sliders in Lightroom. You'll find these in the print module. They were put here to try to help you with this print too dark issue, but it really is a giant kludge and isn't going to affect anything but cause more problems. As you move the sliders, you don't see the screen update, so you're pretty much flying blind. The RGB values are too dark. Fix them. These sliders ensure that the document will print incorrectly in every other application but Lightroom. If you fix the RGB values, then they'll print correctly in all other applications. And guess what would happen if you use these sliders on one of those printer reference images? It's going to print too light. So the best thing you can do is completely ignore this kludge. So let's review. A print may be too dark, but in most cases, a print is just appearing darker than the display. So it's very important that we test this and make sure that indeed the output is sound. We don't have a dark print. The best print in the world will look too dark if it isn't properly illuminated. Take the best looking print you've ever made into a room with absolutely no window light and turn on a tiny little flashlight bulb and see how well it looks. Take it outside, it's going to look completely different. The print didn't change, the illuminant did, and the quality of the illuminant is critical. If the print isn't too dark, but it's darker than your display, then the key is to lower the display backlight conditions so that you produce a visual match. The correct value for white point and backlight are those that produce a visual match. Your mileage will vary. There are just too many factors involved where anyone can provide a set of values that are going to guarantee a match. Every calibration software product can produce a different result. The instrument used can produce a different result. The illuminant you're using to view the print changes. The display technology could be CCFL, which is a fluorescent light. It could be an LED backlight. There's so many different variations going on that you really have to go through a trial and error process of setting both the white point and the backlight intensity such that you produce a visual match. And if you can control the contrast ratio, even better. When you produce a visual match between the print and the display, the print shouldn't appear too dark when properly illuminated. I just can't stress that too often and too many times. The reason that most people say their prints are too dark is that the print is just darker than the display, and the display calibration is the problem here. Or the method in which someone is viewing the print next to the display is inadequate. It's too low. So what you see is what you get is the goal. It's not perfect, but the closer you get to this goal, the fewer prints you'll have to make, the less surprises you'll have, you'll save time and money. And the goal is to get a very close visual match. If you follow these particular recommendations, I think you'll find that you can do that. The ability to produce a match is only as good as the weakest link in terms of the calibration software, the display, the way you view your prints, and the more attention you pay to these important components, the closer you'll get to the two matching. That's about it for today. Thank you very much.